Hello again to CSA Systems. In today's video, we'll show you how to program the NRF24L01 with the ATTiny84. And this is the part 2. In the part 1, we looked at how to program the NRF24L01 with Arduino Uno. So welcome again, and let's get started. So first thing, I'm going to start with the wiring. So the wiring diagram, what we need is ATTiny84, and we need NRF24L01, and we need AMS 11117 5 volt to 3.3 volt, as ATTiny84 works on 5 volt and the NRF24L01 works on 3.3 volt. So that's gonna be like a step down converter to get 5 volt to 3.3 volt. Alright, now time to the wiring. So what we need to do is we're gonna connect pin 1 of the ATTiny84 to 5 volt positive, and the same wire, the 5 volt positive, is gonna be to volt in of the AMS step down regulator, and we connect the volt out, which is the 3.3 volt of the AMS regulator, to the VCC pin of the NRF24. And then what we're gonna need to connect the pin number 14, which is the ground of the ATTiny84. We're going to connect it to the ground of the AMS regulator, and we're going to connect it to the ground of the NRF24L01 module. Next, we're going to wire pin number 7 of the ATTiny84 to the pin number 7 of the NRF24L01, which is MISO, which is master in, slave out. Next, we're gonna connect the pin number 8 of the ATTiny84 to the MOUT-S, which is master out, slave in of the NRF24. And then we're gonna connect pin number 9 to the serial clock of the NRF24. Next, we're gonna connect pin number 10 to the pin CSN of the ATTiny84 of the NRF24, and then we are going to connect the pin number 11 of the ATTiny84 to the pin CE of the NRF24. And for demonstration purpose, or to test communication between two NRF24, so what I did, I added a push button, and to connect that push button we need to connect it to the pin number 13, physical 13, and then on the other leg of the push button is going to connect it to be connected to the ground. And also for receiving from the NRF, from the other NRF, I added an LED, so whenever we push a button on the other NRF module, the LED will turn on this module, and vice versa. So we need 10K resistor for the LED, and we are going to connect it to physical number 12, and from the resistor we are going to connect it to the LED, of course the positive side of the LED, and then the ground is going to be connected to the ground. As you can see, there's so many wires here. So what I did, I actually did this little PCB. As you can see, I have a receiver and a transmitter, and both of them have a push button and LED, push button and LED. So if I press a push button here, this LED will turn on, and if I press this push button here on the transmitter, the receiver LED will turn on, and vice versa. Okay, now we are going to the coding. So this video is based on the RF24 library version 1.3.2. Actually, when I'm recording this video, there is a new version which is 1.3.3, but for whatever reason it did not work for me. There is some configuration issue on their files, so I recommend as of this day 1.3.2. So what I'm going to do is I will show you how to download. I'll get this is the receiver. So to download the RF24, go to Sketch, include library, manage libraries. When done from loading, go ahead and type RF24. Scroll down a little bit and you will see RF24, and as you can see I have 1.3.2 version installed, and if you look at the versions there's 1.3.3, which again it did not work for me, so I will stick with 1.3.2 and I'll show you how to modify to get it work with the ATTiny84 and the NRF24. So I'm going to close this one. So here's how to install it, because I already installed. All you need to do is just go ahead and click install if you, in your case, if it's not installed on your Arduino IDE. Go ahead and close it. So now, before we look at the code, there is something very important that we need to modify. Otherwise, our module with ATTiny84 is not gonna work properly. So what you're gonna need, I'm gonna just minimize this one. As you can see on the step 2, I said modify the RF library to match the pins. What does that mean? So if you go, I'll show you here. If you go to your documents, and once you install the RF24 library, you go to Documents, Arduino, and then go to Libraries, and on the libraries you will see RF24 folder. Go ahead and double click on it, open it, and now what you see, what we need to do, this file rf24.cpp, we need to modify it. So it's highly recommended to go ahead and do a backup. What I do is copy it, paste it, and then I will name this one a copy. I will just leave it this one as an original, and this one is the file that we are going to modify. Make sure that the naming is rf24.cpp, and this is the backup version of the original. So what you need to do, I highly recommend to install the Notepad++ for easy modifying this file. Go ahead and open it. I'll show you here, and here's the file and all the information. Now I'm not gonna tell you what line is it because sometimes it's different, so you need to press Ctrl and F on your keyboard, and then go ahead and look at ATTiny84. Go ahead and find next, and it will take you right away where we need to make the modifications. So on this section you see these pins, we need to modify them. So the PA6 is number 4 and 5 is PA5, and pin number 6 is PA4, and number 3 is PA7. Actually these numbering are incorrect. So what we need to do, you see that PA6, we're gonna do it pin number 6, and 5 we're gonna keep it as it is. So for PA4 we're gonna change it to number 4, and then PA7 we need to change it to 7. So now do you see that the numbering is matching? 6 is PA6, 5 is PA5, 4 is PA4, 7 is PA7. Once you do this modification, go ahead and file and then click save, and then now you can close it as we are done from modifying. And again, go ahead and close that. We are going to look at the code again. Here's the code. So this is the receiver. So if you look at this, what I mentioned is do not include SPI library. So that's what I did. I commented. If you leave it as it is, like this, that's uncommented, you will get an error. I'll show you what kind of error is it. If I go to verify, I'm not gonna upload it right now. Do you see? You will get this error message saying the class SPI class whatever the error is. So if I go ahead and comment it, verify it, you'll see that will say that compiling is done, which means everything is working properly. Plug error ID. Okay, you see there is because there's multiple files. What I'm going to do, I'm gonna go to the folder again. You see that libraries in here, RF. I'm going actually to change that name. I will do .bak, which is the backup. I'll change the file because what is happening, it's looking that there is two files and it's kind of confused between them. So that's why we need to change the format of this file. I'm gonna go ahead and close that one, the receiver again, and now as you can see the message is still there. I'm gonna go ahead and click on verify. Yeah, that's a good thing that happened. You see that it's done complying. It's a good thing that the error pop up, so you can see if in case in your side that happens to you, so you can what to do. The other thing that we need to do, make sure no serial command at all, because the ATTiny84 does not support serial communication. If you look at this one on the void setup, I command serial begin, and on the loop I command the serial print ln, and the same thing on the sending portion of the code. So now once we are done, I showed you how to upload the code to the ATTiny84 on my previous videos. If you go back, and actually I will leave the a link to the video how to program the ATTiny84 in the description, so you can look at it, and if you don't know how, so you can take an idea, because I'm not gonna go through it. So tools, I already select the board ATTiny84, the processor ATTiny84, the clock is gonna be 8 megahertz, port com, whatever is your Arduino Uno is, and what I'm gonna do is go ahead and hit upload. So sorry for that, because I said upload before I explain the code. I'm going to explain the code very quick for you. So if you look the LED, it's connected to the pin 1. If you remember on my previous video how to what is the pin 1 and what is the physical pin. If you look at this map right here, pin, so the pin number 1 is actually a physical pin number 12, but on the Arduino IDE you will refer to number 1, and number 0 is number 13, physical number 13. Again, if you don't know about this, go ahead on my previous video and you will see. If you don't know about this, go ahead and watch my previous video how to program the ATTiny84, and you will I explained everything about the pins and how to program it properly. I'm gonna close that one for now, and I'm not gonna worry about this one. It's just an extra there. The receiver, I made it only one because if you look at this one, I'm actually receiving only one element, so I don't need more than one as the input, because I'm sending one input array, one element, which is right here. See, input 0, so that's why it's just number 1 here. Alright, on the radio I define the CESC SN pins 2 and 3. Again, this is Arduino pins, not a physical number of the pins. Address, again, if you want, you can watch my Arduino how to program NRF24 to Arduino Uno, and I walked through all these, so I'm not gonna explain about the code anymore. So I uploaded the receiver code. I'm gonna minimize this. Okay, the transmitter. Alright, I'm gonna go ahead and upload the transmitter. See if we get any errors. Hope not. Alright, done uploading. So now that means everything is working, uploaded, and it's working just fine. So I will show you here how the transmitter is communicating to the receiver. So as you can see here, how I'm pushing the push button on the receiver and the LED on the transmitter is turning on and off, and the vice versa, when I'm pressing on the receiver push button, it's turning on the transmitter. Alright, so that's all what I have for today's video. If you have any question, please leave it on the comments below. Other than that, I would thank you for watching. Please consider subscribe to support this channel. I'm going to be doing so many videos to help you guys how to do very nice projects with microcontrollers like Arduino, ATTinys, and the ESPs. Alright, thank you so much again, and have a good day.